Yeah. Good evening, students. So in the last class, I had explained the concepts of semiconductors. In that, we had explained the classification of solids based on band theory. Later, we have also discussed the concepts of the diode and also the application of diodes, how to use it as a rectifier, and also how it is used as a Zener diode in the case of voltage regulator. And we have studied the optoelectronic devices and the logic gates. So in the today's session, let me talk about the MCQs on semiconductor electronic devices. Students, as I said, it is basically comparatively a theory-oriented chapter. No much problems or formula related to semiconductor electronic devices. Yeah. Look at the very first question. The majority charge carriers in p-type semiconductor is, you know that in the case of a p-type semiconductor, the number of volts is greater than the number of free electrons. So number of volts is more compared to the number of free electrons in the case of a p-type semiconductor. So number of volts should be the majority charge carriers. So option C. So volts will be the majority charge carrier. Which will be the minority charge carriers then? Free electron. Free electron is the minority charge carrier. And also please remember this p-type semiconductor is electrically neutral. So since it is majority is volts, don't conclude it is a positive type semiconductor. No. P-type semiconductor is electrically neutral. You remember that. And we are going to obtain the p-type semiconductor by doping with the trivalent elements. Trivalent elements like gallium, indium, boron, like that. So option C is the right answer. P-type semiconductor is doped by adding what? See here, arsenic is pentavalent. It contains 5 electrons. Gallium, it is trivalent. Yes, this may be chances are there to become p-type semiconductor. Antimony, phosphorus, bismuth, they are all a pentavalent elements which contains 5 electrons in the outermost orbit. So all these 3 are going to be a n-type semiconductor. The second one, the gallium, is going to be the p-type semiconductor. So gallium is the dopant which is added to the semiconductor to become the p-type semiconductor. Then, what should be the valency of the impurity added to become a p-type semiconductor? You know that p-type semiconductor is doped with trivalent elements. Trivalent elements, it contains the 3 electrons in the outermost orbit. So what should be the valence electron? Valence electrons are the one which are present in the outermost orbit. So the 3 is the number of valence electron in the outermost orbit. So option D is the right answer. In a semiconductor, the concentration of electron is given. number of electron concentration is given and that of hole concentration is given. Now you have to conclude which type of semiconductor it is. Now clearly you can see the electrons is going with a power 10 power 14 per centimeter cube, but the hole concentration is going with the number 10 power 12. So clearly this tells number of electron concentration is much more than the number of hole concentration, isn't it? Electron concentration is 10 power 14. Hole concentration is 10 power 12. So clearly the number of electron is more than the number of holes. So definitely it should be a N-type semiconductor. In P-type semiconductor, there is what? In a P-type semiconductor, when it is doped with a trivalent elements with germanium or silicon, you know that the germanium contains 4 valence electron. When it is doped with a tri-element, indium, gallium, boron, like that, it contains only the 3 electrons. There is one shortage of electron. One shortage of electron will be there in the P-type semiconductor because it is going to be doped with a trivalent. So there will be an absence of 1 electron in the P-type semiconductor. So there will be an absence of 1 electron in the P-type semiconductor. Look at this. The valence impurity of an atom that is added to the germanium crystal to make it as a N-type semiconductor is, to convert into a N-type semiconductor, the valence should be a 5 electron, because in order to get a N-type semiconductor, you know that it should be doped with a pentavalent impurities. Pentavalent impurities means it contains 5 electrons in the outermost orbit. So option B is the right answer. Silicon is a semiconductor. A small amount of arsenic is added to it. Then what happens to its electrical conductivity? Whenever the pure semiconductor is doped with any type, any impurities, if you added, its conductivity will increases. So when it is doped, the impurity will be increases. As the impurities increases, conductivity will increases. So conductivity depends on the impurities. Come to the next question. When the electrical conductivity of a semiconductor is due to the breaking of covalent bonds, then the semiconductor is said to be what? An intrinsic semiconductor. Because intrinsic semiconductor is the one which is going to conduct in its pure state. When semiconductor is going to conduct in its pure state, there will be only breaking of covalent bond. There will be no any impurities. By covalent bond breaking only, if the conductivity is taking place, means it is an intrinsic semiconductor because it is going to conduct in its pure state. So it should be an intrinsic semiconductor. Okay, come to this. There is a piece of copper. You know that copper is a good conductor. And another one is germanium. Germanium means it is a semiconductor, isn't it? Yeah. Now, they are cooled. These two substances are cooled. Cooled means temperature is decreasing. Then what will happen? You know that the resistance of a conductor is directly proportional to the temperature, and the resistance of the semiconductor is inversely proportional to temperature. Since it is temperature is cooled here, this resistance of the semiconductor has to increase. Since this temperature is decreasing, resistance of the conductor should decrease. since it is directly proportional to the temperature. So resistance is directly proportional to the temperature for the case of conductor. Since the temperature is cooled here, the temperature has decreased. Therefore, the resistance of the conductor also decreases. So resistance of copper decreases, but in the case of germanium, it has to increase. So option D is the right answer. Option D is the right answer. Yeah. Look at the next question. To obtain the p-type silicon semiconductor, we need to dope with silicon. In order to get a p-type, it should be doped with what? Trivalent. Phosphorus is pentavalent. Germanium is pure. Oxygen is also 5 electrons. So in order to get the trivalent, it is an aluminum. Aluminum, indium, gallium, boron. They are all trivalent. Electrical conductivity of a semiconductor increases with rising temperature, right? Because semiconductor is going to conduct if you give the temperature or if you give the impurity, if you add the impurity. So conductivity depends on both temperature and impurities. Either by increasing the temperature or by adding the impurities, electrical conductivity can be increased. So electrical conductivity increases with rising temperature. Yeah. 3 semiconductors which are arranged in the order of their energy gap as follows. You know that the energy gap for germanium is almost like 0.7 or to 1.1. For silicon, it is close to 0.3 or 0.4. It is very, very less. Tellurium is very less. So compared to the silicon and germanium, tellurium energy gap is almost nil, close to 0.1 electron volt. So increasing order means option B, tellurium, silicon, germanium. Germanium is having almost close to 1.1. When a semiconductor is heated, what happens to the resistance? Decreases, no? As I said, resistance of semiconductor inversely proportional to temperature. As temperature increases, the resistance of the semiconductor decreases. So in the case of the insulator, forbidden energy gap is how much? You know that forbidden energy gap is the gap between the valence band and the conduction band. If I say this is valence band and this will be the conduction band, the gap between these two will be more than 3 electron volt in the case of a insulator. So more than 3 electron volt means 5 electron volt. N-type semiconductor is electrically neutral. Not only N-type, even P-type semiconductor is also electrically neutral. What is the energy band gap for silicon? Since silicon is a semiconductor, it may lie between 0.7 to 1.1. Maximum you can take up to 1.1 electron volt. The silicon take the energy gap. Remember that value. Forbidden energy gap is not there in the case of conductor. It is almost close to 1 electron volt in the case of semiconductor. But in the case of insulator, it is more energy gap. So which is the relationship? If I say Eg1 is the energy gap for conductors, Eg2 is the energy gap for semiconductor, Eg3 is the energy gap for the insulator. For insulator, energy gap is more than semiconductor. Energy gap in the semiconductor is more than the energy gap in the conductors. So option B is the right answer. Which statement is correct? N-type is negatively charged? No. You know that any type semiconductor is electrically neutral because basically the semiconductor is doped with atoms. Since atom is electrically neutral, any semiconductor, since it is made up of with the atoms, it must be electrically neutral. So option B is the right answer. Both N-type and P-type germanium are electrically neutral. When germanium crystals are doped with phosphorus, you know that phosphorus is a pentavalent element. When it is a pentavalent, how many electrons it contains? Yes, it contains 5 electrons. Since it contains 5 electrons, it must be a N-type semiconductor. Np and Ne or the number of holes and conduction electrons in the semiconductor, then what happens? In the case of a pure semiconductor, you know that number of electrons and number of holes are equal. Number of holes and number of electrons are equal. So number of electrons and number of holes are equal in the case of semiconductor. Yeah. P is one element, Q is the another one. They have the same resistance at ordinary temperature. When you heat it, resistance of P increases. When you give the temperature, if the resistance increases means P must be a conductor. But Q decreases. The resistance of Q decreasing means Q must be a semiconductor. Because resistance of the semiconductor decreases with increase in temperature. So Q must be a semiconductor, P must be a conductor. So what you can conclude? P is a conductor, Q is a semiconductor. Yeah. The impurity atoms which are mixed with the pure silicon to make P-type semiconductor. In order to get a P-type semiconductor, it should be doped with a trivalent, that is boron. Boron is the trivalent. Holes are the charge carriers in. Holes are the charge carriers means it must be a P-type semiconductor. It must be a P-type semiconductor. In the extrinsic P and N-type semiconductor, what is the ratio of the impurities atoms to the pure semiconductor? Please remember, it is of order 10 power minus 7 roughly. 10 power minus 7 is the order of the extrinsic to intrinsic ratio. That is from P-type to N-type. Remember that what values? Hole in a P-type semiconductor is because of one missing electron. Because in the P-type semiconductor, holes will be the majority charge carrier. Because in the P-type semiconductor, we are going to dope with a trivalent. Trivalent means there will be a 3 valence electron in the outermost orbit. So, in order to form a covalent bond with a germanium atom, we need 4 electrons. But in the case of a P-type semiconductor, there will be only 3 electrons. Therefore, there will be one shortage. That shortage will be the missing one. That is called the missing electron. Forbidden gap in the energy bands of germanium at room temperature is about 0.7. or 0.67. For silicon, remember it is 1.1 for silicon. In a p-type semiconductor, the majority and minority charge carriers are. P-type means majority will be holes, minority will be free electrons. At 0 Kelvin, germanium will act as perfectly an insulator, because in the case of a germanium, which is a semiconductor, germanium is a semiconductor. Semiconductor is not going to conduct by itself. Germanium or semiconductor will conduct only if you give the temperature. If you didn't give the temperature, there will be no charge carriers in the semiconductor. If there is no charge carriers in the semiconductor, definitely this germanium should act like an insulator. So it becomes like a bad conductor. Electronic configuration is not required. Semiconductor is cooled. Cooled means temperature decreases, so resistance has to increase. Option B. NP and NEB, the number of volts and electrons in an extrinsic semiconductor. You know that in the extrinsic semiconductor, number of volts and number of free electrons are not equal. If they are not equal, if it is a N-type semiconductor, number of electrons should be more. If it is a P-type semiconductor, the number of volts will be more. So depending upon the nature of the impurity, you can conclude which will be more and which will be less. So option D is the right answer. Without knowing the impurity, you cannot tell which is the majority. But only the thing, for extrinsic, we can conclude the volts and free electrons are not equal. But we can't tell which is the majority charge carriers. You can tell the majority charge carriers only if you know the dopants. Only if you know the impurities which you are adding to the semiconductor, then only we can classify either the electrons are more or holes are more. If you don't know the impurity, only we can conclude the number of volts and free electrons are not equal in the extrinsic semiconductor. Therefore, option D will be the right answer. Yeah. See here, it is an intrinsic semiconductor. If it is an intrinsic semiconductor, you know that the number of electrons and number of volts are equal. So they are equal. Indium. Indium is a trivalent, so it should be a p-type semiconductor. And Fermi energy level in the case of intrinsic semiconductor lies exactly in the middle of the forbidden gap. If it is a pure semiconductor, which is called intrinsic semiconductor, in the case of intrinsic semiconductor, this gap will be almost less than 1 electron volt. The Fermi energy level lies exactly in between this, that is the midpoint of these two. So in the middle of the forbidden energy gap. So in a semiconductor, the separation between the conduction and valence band is of order 1 electron volt or less than that. Intrinsic semiconductor becomes an insulator. When intrinsic semiconductor will becomes an insulator, if you not give any temperature. So at 0 Kelvin. The addition of antimony. You know that antimony is a pentavalent. Antimony is a pentavalent which contains 5 electrons. Therefore, it becomes N-type semiconductor. Resistance of semiconductor at 0 Kelvin. At 0 Kelvin, semiconductor will act like an insulator. You know that in the case of an insulator, there will be no conductivity. When there is no conductivity, the resistance offered should be almost very high, which is close to infinity. Infinity. in a good conductor, the energy gap between the conduction and valence band should be zero, because good conductor means the valence band and the conduction band will overlap. Since it is overlapped between the conduction valence band and the conduction band, the energy gap must be zero. If the energy gap is zero, easily there will be a recombination of holes and free electrons. If there is a recombination of holes and free electrons, the conductivity will increases. If the conductivity is there, there will be no opposition. Therefore, the resistance must be equal to zero. The impurity atom added to the germanium to make N-type semiconductor is arsenic. As I said, in order to become a N-type semiconductor, it should be doped with a pentavalent. So it must be a arsenic. When N-type semiconductor is heated, definitely you know that in the N-type semiconductor, number of electrons and number of holes are comparatively. Number of electron is more than the number of holes in the case of N-type semiconductor. If you give the temperature, the covalent bond is going to break. When covalent bond breaks, one electron becomes free, it will create a hole. So it may equal to either the number of electrons and the holes increases equally, because one electron, if it is leaving from the bond, one hole is created. For example, this is germanium. If it is phosphorus, there will be 5 electrons. This is free now. If you supply the temperature, this covalent bond is going to break. When this covalent bond breaks, this electron becomes free and there will be a hole. So you can see one electron, you can see one hole. So if you go on increasing the temperature, how many electrons will come out from the bond? That number of holes are going to be created. So number of electrons and holes are equally created. So option D is the right answer. So to obtain the p-type germanium semiconductor, it should be doped with indium. It should be doped with a trivalent. Temperature coefficient of resistance of semiconductor is always negative. Please remember, for conductor, it should be positive. For semiconductor, it should be negative. P-type semiconductor is formed. Arsenic as an impurity mixed with silicon. Aluminium is impurity is mixed with silicon. Boron, phosphorus. Phosphorus, boron, aluminium, arsenic. But you should get p-type. P-type means it should be a trivalent. Trivalent means boron. Option C. Look at this. Boron, this trivalent. Phosphorus is pentavalent. This is not possible. Arsenic and aluminium. Aluminium is also possible because it is also a trivalent. Arsenic is pentavalent. This is not possible. So this is N-type, this is P-type, this is P-type, this is N-type. But they are expecting P-type. So both B and C are correct. So option B and C, statement B and C are going to be the right one. So option C is the right answer. In the case of semiconductor, which of the following statement is wrong? Doping increases conductivity? Correct. Because if you add the impurity to the semiconductor, the conductivity increases. Temperature coefficient of resistance is negative? Yes. In the case of semiconductor, it is negative. Resistivity is in between that of conductor and insulator? Yes. Because semiconductor is the one whose conductivity lies between that of conductor and insulator. At absolute zero temperature, it behaves like a conductor? No. At absolute zero temperature, the semiconductor will behave like a insulator. At absolute zero temperature, it behaves like an insulator, not a conductor. So it is the wrong statement. Option D is the wrong. This is not required. Anyway, energy band is going to be classified by using electronic configuration. You know that electronic configuration is given by Pauli's exclusion principle. In the case of a p-type semiconductor, current is mainly carried by volts. Current is mainly carried by volts. At ordinary temperatures, electrical conductivity for the semiconductor varies from 10 power 6 to 10 power 9. That is mho per meter. When the temperature of the silicon sample is increased, conductivity will what happens? As the temperature is given, the covalent bond is going to break. As the covalent bond breaks, it creates the charge carriers. If the charge carriers are created, conductivity of the silicon increases. Conductivity of the silicon increases. So in a p-type semiconductor, germanium is doped with what? P-type semiconductor means it should be a trivalent, boron, aluminum, gallium. All the three impurities are possible because all these three elements, boron, gallium, and aluminum, are a trivalent because it contains only the 3 electrons in the outermost orbit. So it gives the p-type semiconductor. In n-type semiconductor, which are the majority charge carriers? Electrons, no? Yeah. Semiconductor is going to damage the strong current. Due to what? Because of excess of electron. Gallium arsenic is an alloy semiconductor. It is made up of with the 2 elements, that is gallium and arsenic. So it is an alloy of the semiconductor. Ne, NH are the number of electrons and the volts. They are heavily doped with phosphorus. Phosphorus means it is a pentavalent. It contains 5 electrons in the outermost orbit. So number of electron is more compared to the number of volts. Number of electrons is more compared to the number of volts. N-type semiconductor is doped with phosphorus. P-type should be doped with indium. Arsenic, phosphorus, both are pentavalent. Indium and aluminum both are trivalent. Aluminum and boron are also both trivalent. But in order to get a N-type, it should be doped with pentavalent elements. P-type should be doped with a trivalent. So first one, to get N-type semiconductor, it should be doped with the phosphorus, that is pentavalent. And in order to get a p-type semiconductor, it should be doped with a trivalent. N-type semiconductors will be obtained when germanium is doped with phosphorus, aluminum, arsenic. No, phosphorus is possible, arsenic is possible. Both A and C are pentavalent. But aluminum is not possible because it is trivalent. In order to get a N-type means it should be doped with pentavalent. So option A and C are correct. So both A and C. The state of energy gained by the valence electron when the temperature is raised, when the electric field is up, applied is called as what? Conduction band. Because the conduction band is going to come into picture only if the electron is excited to the higher energy state. How to take the electron to the higher energy state? By giving what? Temperature. By giving thermometer, I mean heat energy. By raising the temperature, you can get the electron, you can take the electron to the outermost orbit, that is conduction electron or conduction band. So option B is the right answer. To obtain the electrons as the majority charge carriers, the impurity should be doped with what? To get majority as electrons, it should be doped with a pentavalent. So for germanium crystal, the forbidden energy gap is about 1.12 into 10 power minus 19 joule, because they're expecting in joule. You know that for germanium crystal, it is approximately close to what? 0.6 electron volt or 0.7 electron volt. But how to convert electron volt to joule? You know that 1 electron volt is 1.6 into 10 power minus 19 joule. So you just multiply this 1.6 with either 0.6 or 0.7 or 0.8, because germanium is a semiconductor where it is going to be closed with the maximum of 1 electron volt. So for germanium, either you can take 0.6 or 0.7. If it is silicon, you can take approximately 1.1 electron volt. Since it is a germanium, either you can take 0.6 or 0.7. So you multiply this 1.6 into 10 power minus 19 to this. Approximately for 0.7, I think you are going to get this. 0.7 into 1.6 into 10 raised to minus 19. You will get 1.12 into 10 power minus 19 joule. Pure semiconductor behaves like a slightly conductor at room temperature. Which is the correct relation between the forbidden energy gap? You know that the forbidden energy gap is more in insulator compared to semiconductor than conductor. So option B. Energy band gap for germanium is 0.7. For silicon, it is 1.1. So option A. P-type semiconductor or adding impurity element of what? P-type. P-type means it should be doped with a trivalent, phosphorus, arsenic, bismuth, or N-type semiconductor. This boron is a P-type semiconductor because it is doped with a trivalent. So option C is the right answer. At room temperature, P-type semiconductor has large number of holes, because for P-type semiconductor, number of holes is more than the number of electrons. In intrinsic semiconductor, number of electrons and holes are equal. Number of electrons and holes are equal in the case of pure semiconductor. Pure semiconductor means an intrinsic semiconductor. Valence band and conduction band are overlap. They are going to overlap only in the case of a conductors, or also you can consider as a metals. So in the case of metals, both forbidden energy gap will be 0. That means both energy band, that is valence band, and the conduction band will overlap. Which impurity is doped in silicon to form a N-type? N-type means it is a pentavalent. For pentavalent, it should be doped with arsenic. In a semiconductor, there is no free electron any temperature? No. If you give the temperature, the covalent bond will break. Therefore, it creates the electrons. So this option is wrong. Number of free electron is more than the conductor. It may be because of temperature, the covalent bond breaks. There are no free electrons at 0 Kelvin, right? No. If you not give any temperature at 0 Kelvin, the covalent bond will not break. Bond will not break. Therefore, there will be no free electrons. Energy band gap is maximum in the case of insulator, because for the insulator, the energy gap is more than 3 electron volt. The process of adding impurity to the semiconductor is called as what? Doping. When phosphorus is added, phosphorus means pentavalent and antimony. Even antimony is also a pentavalent. They are mixed with the germanium, means it should be doped with pentavalent. So the majority charge carriers will be electron. So electron are the majority charge carriers. Therefore, it becomes N-type semiconductor. To a germanium sample, traces of gallium are added. Gallium means it is a trivalent, so it should be a P-type semiconductor. For non-conductors like insulator, what should be the energy gap? It should be more than 3 electron volt, so 6. 0.8, 0.3, 1.1 is for semiconductors. Donor type means, donor means it is donating 1 electron. Donor means donating electron. Donating electron means it should contain excess electrons. Excess electrons are there means number of electrons will be more than number of volts. So definitely it should be a which type of semiconductor? N-type semiconductor. So pentavalent elements. Look at this. The difference in the variation of resistance in the temperature in the case of metal and semiconductor. There will be a variation in the number of charge carriers. Option C. Why there is a number of charge carriers? As temperature gives to the conductors or semiconductor, the covalent bond is going to break. Because of this covalent bond is going to break, there will be a charge carriers. So there is a variation in the case of charge carriers as the temperature is given to the substance. The charge on the hole is equal to the charge of proton because hole is a positive charge carrier. Hole is a positive charge carrier. So it should be a proton. When germanium is doped with phosphorus, phosphorus means pentavalent. Number of electrons should be more than the number of holes. So more negative current carriers. Germanium specimen is doped with aluminium. The concentration acceptor atoms. Acceptor means holes. Intrinsic semiconductor electron hole pair. Electron hole pair is 10 power 19. Then what is the concentration of the electron pair? You know that NENH should be equal to N square. Number of electron into number of hole concentrations should be equal to number of electron hole concentration square. Electron concentration you have to find. Hole concentration is 10 power 21. Electron hole concentration is 10 power 19. Square is there, so 10 power 38. So number of electron concentration is 10 power 38 by 10 power 21. So 38 minus 21, 10 power 70. So option E. Remember this formula in this chapter. related to semiconductor, only this is the formula to find the concentrations. Number of electrons into number of hole concentration is equal to number of electrons and holes recombination square. Which of the following is negative temperature? You know that negative temperature is for semiconductor. Semiconductor means germanium. In semiconductor at room temperature, valence band is partially empty, but conduction band is partially filled at room temperature. Regarding a semiconductor, which one of the following is wrong? There are no free electrons at room temperature. At room temperature, you have given temperature, so there will be creating a number of charge carriers. There are no free electrons at 0 Kelvin. Correct. At 0 Kelvin, there will be no free electrons in the conduction band, but there will be electrons which are in the valence band. No, but conduction electrons are 0. Conduction electrons will be 0, but the free electrons, valence electrons will exist, but they are telling no free electron. So this is the wrong. So at 0 Kelvin, since you have not given any energy, no current. No current means there will be no flow of electrons. So at room temperature, there will be no free electrons is the wrong statement. Option A. Because room temperature means you have given the temperature 273 Kelvin. If you give the 273 Kelvin, the bond is going to break. If the bond is going to break, definitely there will be an electron. Since there will be an electron, definitely option A is the wrong statement. They are asking wrong statement only. Which of the following statement is true related to N-type semiconductor? Donor level lies close below the bottom of the conduction band. Yes. Donor level will be very close below the conduction band for the N-type semiconductor. For P-type semiconductor, it is just above the valence band. Choose the correct statement. When we heat the semiconductor, its resistance increases? No. Since resistance is inversely proportional, if you heat the semiconductor, resistance has to decrease. Resistance is inversely proportional to the temperature. P-type semiconductor means it should be a trivalent. Gallium is possible. Boron, aluminum, all of this. Because all are trivalent. It contains 3 electrons in the outermost orbit. A piece of semiconductor is connected in series. On increasing the temperature, what will happen to the resistance? Increases. Because for series, resistance effective will increase, right? So it should increases. Intrinsic semiconductor is electrically neutral. Extrinsic semiconductor having large number of current carriers would be electrically neutral. This is what I said. Any type semiconductor, either P-type or N-type, all the semiconductors are made up of with the atoms. Since all atoms are electrically neutral, even any type semiconductor must be electrically neutral. Ne and Vd are the number of electrons and drift velocity in the semiconductor. Ne and Vd will decreases. For the temperature is increased, there will be opposition. Because of the opposition, the movement of the electrons will decreases. So drift velocity decreases, but the number of electrons will increases. Option A. In extrinsic semiconductor, you know the gap between conduction band and valence band is about 1 electron volt. Resistivity of semiconductor depends on the atomic nature. Electric current is due to the drift of electrons in the case of metal as well as in the case of semiconductor. But in the case of semiconductor, addition to free electron, there will be volts. So both A and B. Energy gap in the silicon is 1.14. What should be the maximum wavelength? You know the formula for the energy, which is given by Hc by lambda, or you can also given by the formula 1240 by lambda. You can substitute this electron volt energy, then you can find the lambda. You will get 10,088 Armstrong. I think this I explained in the chapter called dual nature. Same formula, you can use it here also. But you will get in nanometer. If you add one more zero, you will get it in Armstrong. Which of the following diagram holds good for the N-type semiconductor? For the N-type semiconductor, valence band gap and conduction band gap is 1 electron volt approximately. Conduction band and this impurity level is just below the conduction band. This is very close to this. So it is N-type, no. For N-type, it is close to conduction band. Fermi energy level. Mobility of free electrons is greater in that of free holes, because electron is greater compared to free holes, because mass of hole is more, mass of free electron is less. Since it acquires low energy to continue their motion, since mass is less, it acquires very low energy to continue. Relation between the number of free electrons and temperature, please remember, it is number of free electrons is directly proportional to temperature power 3/2. Please remember that. Electron concentration in the N-type is any. This conductivity is there, sigma. Then what is the impurity concentration? That quarters. That impurity concentration. So here they have given in terms of centimeter. This is in centimeter square. You have to simplify. Since it is a impurity concentration, it is having very, very high in the case of germanium of order 10 power 16 per centimeter cube. No need to solve because we have not learned the formula related to that. Try to remember. Which of the energy bands diagram shown in the corresponds to semiconductor? This overlap is not possible. This is also not possible because it is not completely filled. And maybe this is equal because energy gap is more than the Boltzmann constant, KT. Option C. Yeah. 97th is also same based on that. Carbon silicon energy gap. In that energy gap for the carbon is more compared to silicon. Energy gap in the case of carbon is more than the energy gap in the case of silicon. You know that semiconductor doped with a donor impurity becomes N-type. In semiconductor, mobility of electrons and holes are this. Mobility of free electrons is more compared to the mobility of the holes because the mass of electron is less. Since mass less, more electron can occupy. Doping of intrinsic semiconductor is to increase the concentration of the majority charge carriers. It is used to increase the majority charge carriers for intrinsic semiconductor. So in the next class, I can take up the concept of this semiconductor diode, students. So whatever the questions we have discussed now, it is only a basic concept of semiconductors. In the next class, let me talk about the two concepts. One is diode, the another one is the logic gate. Diode and logic gate we can discuss in the next class, so that I can complete semiconductors in the next session, and I can start up the another small chapter, that is electromagnetic waves, which is the last chapter in the part 1 book. So I can continue with that after completing this semiconductor. I hope you got the today's session. Thank you, students.